guys, we are on the last section of this chapter that we're going to do, and it's almost spring break, so hang in there. So, quadratic inequalities, they're very, very similar to when we were graphing inequalities, and then we graph systems of inequalities. We're doing the same thing, we're graphing and we're shading, okay? And at this point, we should be pretty good at graphing parabolas. So the different types of inequalities, we have y is less than, y is greater than, y is less than or equal to, and y is greater than or equal to, and they're all to ax squared plus bx plus c, which is our quadratic form. Okay, it's our quadratic form of an equation. It's the quadratic form of an inequality. So when we have a graph of a quadratic inequality, the graph, so the shaded area and the line if it's solid, not if it's dashed, consists of the graphs of all ordered pairs x, y that are solutions of the inequality. Okay, so first this is kind of like a warm-up. We're checking the points. So one, I'm sure you guys like it, I think it's a terrible thing, is that they actually do the graphs for you on these notes, and I'm not totally sure why. I think it might have been a fluke, but we kind of have to deal with it. So, but sometimes it's convenient. I'm sure you guys love it. So sketch the graph of y equals x squared plus 2x minus 3. So for the sake of keeping this video short, we are going to do some sketching, but we're not going to sketch it right now. So you can just assume that they sketched it correctly. So plot and label the points A, B, and C. Well, they actually did that for you. They put in A, B, and C. Okay. So I want to see which two lie inside. So inside is this nice part. Okay, I'll color it, let's see, with green, let's say. So this is the inside. Okay, it's the part in the U. It would be like the mouth of the smiley face. And I'll color the rest of it red. Okay. This is the outside. Okay. So, I just figured out I can have a purple pen. Let's do that. So I can see that B and A, so A and B, are inside in that green area, while C is outside. So A and B are inside, while C is outside. So now, all it wants you to do for this checkpoint is put these points in and tell if they're inside or outside. So inside is green, outside is red. So let's look at 2, 1. So here's 2, up 1. Okay, that's going to be an outside. Which would mean it wouldn't be a solution. Negative 3, 4. Negative 3, up 4. That's going to be inside. So go ahead and do that for 3 and 4. You probably don't need to pause the video to do that. You can do that right now, or if you need more time, you can pause it. Okay. So let's scroll up. So now the steps to sketching the graph of a quadratic inequality. Okay. So there's 3 steps. First, we need to sketch the graph of just the equation. So you're going to ignore the inequality sign that's there and just graph the equation. So exactly like 9.3. And you use a dashed parabola. So dashed lines if it is less than or if it is greater than. And that shows that the points are not solutions. Okay, so if they lie on the parabola that is dashed, they're not solutions. But if you sketch a solid parabola, which is what you do if you have greater than or equal to and less than or equal to. So if you have that line under, okay, then you can know that it's a solution. So they are solutions. And the parabola that you drew separates the coordinate plane into 2 regions. Okay, it separates it into the inside and the outside. And then to find out which part you should shade, you're actually going to test one point. So one point that's not on the line. So usually 0, 0. If it's not on a line, 0, 0 is the best to test. So if you test a point and it is a solution, then you shade its region. So if it comes out to be a true statement, you shade it. If not, you shade the other region. So it's very, very similar to what we did before. So now let's look here. Let's look at example number 2. So example number 2, we need to sketch the graph of y is less than x squared minus 4x. So we need to use the grid given below. I know it already has the picture in the graph for you. We're going to pretend it's not there. This graphing is good for us. It's good practice. So I should see all the work that I put on this page on your page. Okay. So we know that it is a y is less than. So we need to use a dashed line while we're graphing. And we also know, because this is a 1 here and that's positive, our parabola is going to open up. So now we just need to graph y is equal to x squared minus 4x. I can see that I have an a of 1, a b of negative 4, and a c of 0. So I can now plug that in to x equals negative b over 2a. So I get negative 4 over 2 times a, which is 1. So it'll be 4 over 2, which will be a 2. So I'm going to make my table over here. My vertex is a 2. So then I have a 3 and a 4, and a 1 and a 0. So now let's plug those in into y equals x squared minus 4x. So y equals 2 squared minus 4 times 2, which gives us a 4 minus 8, which will be a negative 4. Let's plug in a 1. Y is equal to 1 squared minus 4 times 1. Well, that'll be 1 minus 4, which will equal a negative 3. And lastly, y is equal to 0 squared minus 4 times 0, which will just equal a 0. So we can plot those points. 2, negative 4, 1, negative 3, 3, negative 3, 0, 0, and 4, 0. And again, we said because it doesn't have a line under here, it's just a less than, it has to be dashed. Okay, so now I have the parabola. So I need to figure out where I want to shade. Okay, so now let's test a point. And they want to test the point 0, 1. So that works. So we'll go to 0 and up 1, and it's over here. So I can see that would be an inside point. So I'll plug in for y is 1 and x is 0. So that gives me a 1 is less than 0 squared is 0 minus 4 times 0 will just be a 0. Is 1 less than 0? No. So this is false. Okay. Because 1 is not less than 0. Okay. The ordered pair 0, 1 is not a solution. And because 0, 1 is not a solution, or isn't a solution, it is, let's see, and it is inside the parabola. So the graph of the y is less than x squared minus 4x was going to be all the points outside. And because it's dashed, comma, it's not on the parabola. So it's all the points that are outside. So we shade all out here. And you can see that we're not shading that point that we tested that was right here. This is the point 0, 1 that we tested, and we're not shading it because it's inside and it didn't work out for us. So instead we're shading the outside. Another trick that I like to use is, okay, it's saying that y is less than. So I'm going to go just to my y line, and if y is less than, I can look down. Okay, y is less than down, and that's where I shade. Okay, and that also almost always works for you. I'm pretty sure it works all the time. So here y is less than, so y is down. I go down, and now I'm outside the parabola, and that's where I'm going to shade. And so this is what yours should look like. Okay, let's go on to example number 3. These really aren't that much harder than section 9.3 graphing them. It's just one more step, and it's a step that we've done before, so it's pretty familiar to us. So 9.3, again, we're graphing. So this time we're graphing y is less than negative x squared minus 2x plus 3. So we need to sketch the equation, and we can say that, let's see, it actually here says it's less than or equal to, so I guess we'll go with that. We'll change this part up here. Okay, so if it's less than or equal to, we're going to use a solid line because the inequality is less than or equal to. And we can also see that this is a negative 1 here. So my a is negative, so my parabola is going to open down. So it's going to be like a frowny face. Okay, so now I do need to sketch the graph, and we are going to practice sketching. It's basically our last one. We can do it. Okay, negative x squared minus 2x plus 3. So I can see I have an a of negative 1, b of negative 2, and a c of 3. So I can do x is equal to negative b over 2a, which is a negative negative 2 over 2 times negative 1, which is a positive 2 over negative 2, which is a negative 1. So now I have an x of negative 1, so I can make my table over here. So we're going to make our table right here, our table of values. So our x is going to be a negative 1, which means I'll have a 0 and a 1, and a negative 2 and a negative 3. Okay, so I'm going to plug those into y is equal to negative x squared minus 2x plus 3. So with negative 1, I have negative 1 squared minus 2 times negative 1 plus 3. That'll be a negative 1 plus 2 will be a 1 plus 3 will be a 4. So it'll be a y is equal to negative 0 squared minus 2 times 0 plus 3, which is just equal to 3. This will be a 3. This will be a 3. And I have y is equal to negative 1 squared minus 2 times 1 plus 3. Negative 1 minus 2, negative 3 plus 3 is a 0. So this will be a 0, and this will be a 0. So now I can plot those points. I have negative 1, 4, 0, 3, 1, 0, negative 2, 3, and negative 3, 0. And we said we're using a solid line here. So the way they like to test their points, okay, or to figure out where to shade, is they test a point. So they're actually going to test the point 0, 0, okay, which we can see is inside the parabola. So for 0, 0, I plug in 0 for y, 0 for x. Get 0 is less than or equal to negative 0 squared minus 2 times 0 plus 3, which is just a 3. So I have 0 is less than or equal to 3. Well, that is true. Okay, so because 0 is less than or equal to 3, the ordered pair 0, 0 is a solution, and the point 0, 0 is a solution, and it is inside the parabola. So the graph is all the points on and inside the parabola. It's an and sign because it can be on since it's solid, and it's inside, and so that is where I shade. My way of doing this is that I see where, okay, so this is y is less than, correct? Y is less than. So I go to my y line and I go to less than. Well, I know less than is down. Okay, all the y's that are less than or smaller than are going down. So I have to shade down, which means I'm shading on the inside. That's how I reason through it. So whichever way makes sense to you. Either way, you shade it inside. So last one, we have y is greater than negative x squared plus 4. So I have to graph, even though it does these for you, and it already has the graph, I want you to practice graphing, so I should see your writing, your drawing on top of the graph. So, first I need to graph y is equal to negative x squared plus 4. That gives me an a of negative 1, a b of, oh, there's no x's, so it's 0, and a c of 4. So x is equal to negative b over 2a. gives me a negative 0 over 2 times negative 1, which is just a 0. So I make my table of values, and 0 is my vertex. So then 2 to the right is 1 and 2, and to the left is negative 1 and negative 2. Okay. So to plug in 0, I have y is equal to negative 0 squared plus 4, which is a 4. For 1, y is equal to negative 1 squared plus 4, which is a 3. 1 plus 4 is a 3. So this will be a 3. This will be a 3. So now I just have to plug in 2. So y is negative 2 squared plus 4. Well, that's going to be negative 4 plus 4, which is a 0. So 0 here and a 0 here. So I have 0, 4, negative 1, 3, 1, 3, negative 2, 0, and 2, 0. And I know because of this is greater than, I need to make a dashed line. There's no line under that says equal to, so it has to be a dashed line. Okay. And then I know, okay, so my way says y is greater than. Well, the y is greater than go up, and up goes outside, so I have to shade outside. If that made sense to you, you can do it that way. If not, you can test a point. Let's say we test this point here, 0, 0. So I get 0 is greater than negative 0 squared plus 4, which is 0 is greater than positive 4. Well, that's not true. So that 0 right there is not a point, and it would not get shaded, so you would know you would have to shade outside. Okay, go ahead and try number 6 on your own. You got this. It's almost spring break. Last section of this chapter. See you guys tomorrow.